morning, guys. Today our topic is resistance welding. Okay, so there is so many types of resistance welding. Uh, the weldings are generally from arc welding, solid state welding. In these are the weldings. But as an electrical engineer, we are specifically want to know about the resistance welding because it is directly deals with our electricity and in utilization systems, and this type of resistance welding will helps us to works us in this area uh, for this electric power utilization. Okay. So first, what is resistance welding? Resistance welding basically coming from um, uh, arc welding categories. Okay, or you may say this is also come from um, pressure welding. Okay, so guys, we have to know that how the resistance is applied here, and the property of resistance causes is a welding material. Okay, so this is the main things of main fundamental things of resistance welding. Uh, uh, Now I am going to share this. Look, in this case, there is two electrodes are there. If we apply some high voltage, some high current, because heating is done by only current, because the heat equals to I square RT. So, we apply some high voltage at the primary stage, primary of the transducer, but it just stepping time. When it step down, then it create voltage level is slow, but as we know the power is same for the both cases. Just primary cases P1 power and the secondary cases P2 power are same. So if we reduce the level of voltage, then we have to increase the level of current. So then in this case high voltage is applied for the primary case, but secondary case it's coming the high current. So that whenever high current is flowing through these two electrode, and in between these two electrodes two plates are there. Okay, the eight plates are there, and then these plates creates a resistance. So this resistance is whenever high current is flowing in a spot, a current is created. A spot is created where high resistance will be created. Then high resistance causes a fusion point temperature. Yes, sir. In this temperature causes is then what happens in this temperature causes is the fusion temperature, and which these plates are just like the plastic stage, and then it will just welded in here. Okay, and simultaneously whenever this plastic stage is reached, then we are apply some pressure. You can see some pressure are there. Whenever we apply some pressure, then it will be joined together. This is the main things of the uh, this is the main things of the electrode. Okay, uh, hope guys you can understand this, and I again show you the some pictorial things. Look, here is some pictorial things are there, a diagram. You can really from easily understand this. Okay, guys, you can see here the main components is are required. Generally, the one is transformer and another is two electrodes. Two electrodes are coming from generally a copper material. Okay, this copper material, and it is a pin head. It's a pointed or pin head electrodes are used. Generally, electrodes are very nozzle type or needle type or some pin type tips are formed. So what happens whenever we apply some high current across these two electrode, and between these two electrode we are applying two plates, which one we want to join. Then what happens as it is coming through a pin point in electrode point, and then the current is flowing to the pin point electrode. But whenever it is a copper based, so no resistance or less resistance is there. But whenever we apply some plate, just like iron and copper, etc. Then what happens is not copper, sorry, but this is iron or some alloy which resistance is high. Then what happens? The current is flowing through the pin point, or it is created a spot, or in through spot current is flowing through one electrode to another electrode. But when in this spot, what happens? Temperature became high. What is the temperature? Temperature is generally heat is I square R T and K. What is K? You know, I is the current, R is the resistance of this metal, and T is the time for how many long, how much long you apply this current, and K is the constant. This is called thermal constant. Okay, and this depends on welding force, parts of geometry, etc. Okay, so whenever this spot is created, through this spot high current is flowing. So what happens in between this spot, in between two plates, or this spot area, it became reach the plastic stage, or you may say it's a fusion stage. At this moment, this metal become just tends to melt, not clearly melt, just tends to melt. Okay, then what happens? At that moment we are applying some force. You can see that through this electrode we are applying some force by hydraulic force, by pneumatic force, or some any mechanical force are there. Then what happens in this spot area where the metal became just a fusion stage or the plastic stage, then it became joined together, and within few seconds we release this, then it will again pulled and it became joined together from this spot. Only for this spot, no other parts will be joined together. So this is called the spot joining. And you can see, if we electrodes are there and two metals plated, generally then a lap winding are covered by this material, by this mechanism. So this is the lap winding, and this spot is became heated, and then whenever we release the heat and pressure also, then it's become joint. Okay, so what happens? It is generally for used for the lap joining two plates, and you just remember the thickness is generally 12.7 millimeter max to max. Okay, so this type of plates can be joined. Okay, so this is the main thing. Somewhere it is asking in what type of current is applied it for this purpose, for the spot joining. In spot welding or spot resistance welding, we are applying generally the AC current. Okay, because we are using direct bridge transformer, so in this case we are using direct AC current. Okay, now uh, in this case, one arm or one electrode is fixed. Generally, lower electrode is fixed and upper electrode become movable to just way to adjust the uh, this thickness. Okay, and next, guys, if you have any question, you may ask me. And now I am going to the next point, that is seam welding. Oh, prior to going that, I want to show you something. Look how it is possible. It is what is going there. That is the first. The two electrodes are there. This is the fixed electrodes. This is the lower portion is the fixed electrodes. This is the working principle. Okay. Then two metal plates are one electrodes is upper, one by one two electrodes are coming, one by one is two electrodes are coming, and whenever whenever it's just coming to the contact, then force and electricity applied. First of all, you can see whenever they adjusted and they touch together, then we power on the electricity. Otherwise, now it is not power is applied. So whenever power is applied, the current is flowing through it, and if we apply some power before it, then what happens? Here some sparking will occur within this from 1 to 2 millimeter, it is sparking is applied. But we don't want to apply sparking. That's why whenever the all adjustment is over, two electrodes between these two electrodes, metal are joined, then we only apply some power. Okay? And after some times, after few seconds, what happens within this area where the current is flowing, this area will be melted or just like going to the plastic stage, or you can say it is the fusion point. Then it will just join and we release this, and the electrode electrode gives electricity, and then what happens? It is joined. In this way we can all about your spot welding. Now I am going for the now this is the sorry, I am coming for the projection welding. Now you can see in spot welding, only one spot is created because one electrode or one pinpoint electrode is coming to the contact. This pair of pinpoint electrode is the contact. But in the projection welding, there is say two, three, or maybe four point of contacts will be provided, so that there is not only one point, one spot is created. There is a it is more than one spot, more than two, more than or one spot will be created, so that joining will be more efficient and more robust. That is the projection welding, and the other things are all the same as the spot welding. Okay, next I am going to the seam welding. What happens? Seam welding, just like the spot welding, but what happens? Electron just converted or replaced is into a roller. So this is a ruler. This is also a ruler. This ruler are the made of the copper, and this can rotate. This can rotate in this direction. You will see these are the rotating one direction. So what happens? This lower portion are the fixed, and the upper portion is up and down adjustable. This is for only for adjustable, and these two roller can rotate it in axis. What happens whenever we provide some electricity and it starts to rotate? So what happens? These joint are these joint are coming from this side to this side. So what happens? It's not only one spot is created, it is together whether more than one, means throughout the line of spot is created. So the two plates are joined in a line, not one spot. Throughout a line, it will be created some heat, and this heat it just melt these two contact point, and it will join. So what happens in not only one spot join, there is a line of joining, line of spot joining. Okay, so this is the same way. You can see the working principle. This ruler is rotating. This ruler is also rotating. So whenever these two rulers are rotating in opposite direction, and if you put some material between these two rulers, what happens is uh, this material this material is passes from one side to another side. It is started from this side and it is going to the another side. So what happens? We are applying some high current through this roller. So whenever this contact position is coming, then what happens again? It is occurring just like a spot welding. In a spot, there is this, the metal became melted, or it is tends to melt. Maybe it is going to the fusion point, or it may be going to the plastic stage as per our application. Okay, whenever this position is melted, then this metal became joined, and because two sides of the two contact sides of metals are melted, so it's became a joining. And whenever this roller is rotated, then what happens? Then these two plates are moving from one side to the another side. So what happens? This is the throughout a line it will be joined. Okay, this is the main aim of this seam welding. Okay, other concept, other materials are just like a normal spot welding. Okay, and now what are the advantages? Just you can see this is the advantages. Not only one spot are required. There is at a time throughout this line we can join it. Okay, and now it is coming flash joining or the part joining. Uh, Now, how could you mm, how could you understand that the welding resistance welding have create arcs, and in this case in this case resistance welding create arcs. But before two things, there is a no production, nothing was, arcs was not produced. So in this part joining or the flash joining, arc is produced. How it is possible? In above cases, what happens? We apply some power whenever they are coming to the contact. But in flash or bar joining, we applying power before they are coming to the contact. Whenever the clamps are moving, look, whenever these are the clamps in the bar joining or flash joining, there is a only rod type or bar type materials can be joined. In prior section, where the spot welding and the spot welding, seam welding, and the spot welding and seam, and another parts whatever I am told, that is, you can see projection welding. There is a power is applied, and when they are coming to the two electrodes are connected, circuit is completed, then we apply power. But in flash joining, we apply power before it circuit is completed, or the line path of current flowing is completed, or you may say whenever the two electrodes are apart from each other. Okay, so the procedure and construction, you can see this is the electrode, this is the electrode, and this is a clamp actually. This is a clamp type electrode, and two materials are joined together. Okay, so two materials we need to join together at this position. So we are applying some part here, and this is a similar type of metal are used, and this area is generally 320 millimeter square. It is max to max we can apply for joining for the 320 millimeter square. And these clamps are used. These clamps are generally made of copper, and we are applying some electricity across this. This is a positive negative, or you may say this is a neutral or line. And whenever apply some electricity, when they are not connected, they are apart from each other. So whenever it is coming near to the 1 to 2 millimeter range, then what happens? A spark is created. Whenever spark is created, or you can say this is a arc is created, then huge temperature will be increased. And whenever the huge temperature will be increased, then this part of this material became melted, or you may say this is the plasma state, or you may say this is the plastic state. Then what happens if you apply some force, and one clamp is fixed and another clamp is movable. So one by one step we can apply some force, and we coming together each other. Then what happens, some molten metal will be going out from here, and then we just stop it. And what happens then, this the residual molten metal became the joining element, and it's joined the total this bar or this bar. Then we release the electricity as well as the pressure. Then these two bars or the two rods became joined face to face. This is called the bar joining, and this is a flash is coming out. That's why this is also called the flash joining. This is the fundamental things of resistance joining. You can I think you can understand these things. And what are the advantages and disadvantages is of this type of joining? Because we have already we have seen this is the resistance joining. Meaning one is the spot joining, another is the projection joining, another is the seam joining, another is the this is also seam joining, and this is flash but the bar joining. So one uh, each and every type has some disadvantages and advantages. Look, spot welding is applied for a pinpoint joining where only within joining is required only for the spot. So only is a small material where I want to join, then we use the spot material, a spot joining. Where the two or three many specific distance we want to join, then we can use the projection welding. And whenever throughout the line we want to join, throughout the line we want to join, and the joining should be more robust than the spot and projection joining, then we have to apply some seam welding. Okay, and this is the seam welding. But these all things are applicable only for plate, or it is applied for the lap welding, not for bar welding. And the flash or bar welding only can apply for the bar welding, not for lap or the plate joining. So this is the main difference between the flash or bar welding and other things. Because whenever we need some join some plates, then we have to apply this type of welding, and we have to whenever we need to join some part or some bars, some rod, then we have to apply some part or the flash welding. Okay. Now I am coming to the percussion welding, and in this case we are applying generally AC. Okay. And now another last point for the resistance welding. This process is called percussion welding. Okay, so it is a new topic, and if you go for any interview, and if once you can say that I know the utilization, then they may be asked this particularly, because here is some application of the capacitor charging and discharging, and some rectifier for making DC. Look, first case is the percussion welding is done under basic based on your DC supply. Okay, so whenever you apply some DC supply, then you have to produce a DC power. How could we produce? Because generally we are applying some rectifier stage. So this is the transformer, and this transformer is generally doing some AC current, and which have some frequency. Okay, just remember it has some frequency, because we know the AC current has frequency. So this whenever this secondary power is rectified, then we get some DC, but this DC also have some frequency. You say, how is it possible? DC have some frequency? No, actually, I am just want to show something. In that DC is not continuous or smooth DC here. Okay, just like this, I want to show. Uh, I want to show. Look, this is the DC. This is the AC supply. This is the AC input supply. This is the AC input supply, and whenever we apply some DC, it will looks like this, looks like this, or you can say this is also look like this. But here this is at some uh, all voltage are not same. This is not, this is coming whenever this is coming, this type of DC voltage is coming. So this DC is not continuous DC. So whenever within this point only we get DC, within this point we never get any power. Within this point we are getting some DC. Uh, in this point we don't get anything. In this, sorry, in this point we get, but in this point, in this curve we don't get. Just like this, in this point we have voltage is so in this way we can understand the DC is not fixed, and this type of DC is not possible. This is a small type of frequency or cutoff is there, and this DC is applied to a charging of a capacitor. Look, just like this capacitor. Whenever the switch is here, switch is connected here, and then what happens? Since current is flowing in this direction or any direction, sometime whenever they for a one half uh, point, they what happens, it is one distribution. So what happens, a capacitor will be charged, capacitor will be just charged, but at that moment whenever we just whenever just the switches whenever we just now after charging, whenever we just connect to the switching to this point, here is an electrode, and this is the bars, earth is there. Here is the electrode, clamp type electrode. One is fixed, one is fixed, and another is movable. This is one is fixed, one is fixed, and another is movable. Okay, it is movable or vice versa. So what happens? This is also a electrode. Okay, so some positive negative connection is there, positive or negative connection is there. And so what happens? So what happens? The current is flowing through this rod, and this portion became just coming to the contact. And what happens? It is created some resistance, and whenever it is created some resistance, because due to here some air gaps is there. So the procedure is that whenever we charge this capacitor, and here is whenever connected to this connection. So what happens? This is fixed and this is movable, and we apply the power prior to the movement. We are applying some power, but whenever it is coming nearer to each other, whenever it is coming nearer to each other, so after a certain distance, the distance is very less. Yes, whenever it is coming to the certain distance, then what happens? Here is some spark is created. There is some spark is created, but this time of sparking is very for less time. The time is just 0.1 second, 0.1 second. Okay, because you can see this is it's some frequency like DC supply, some not continuous supply, and and then it will get some charging time and it will get some discharging time. So within this discharging time, within this charging or discharging in time, it will charging time it will get charged, and discharging time it will just apply some power. And whenever it is coming nearer to the 1 to 2 millimeter, then a spark is created, and gradually this movable portion, this movable electron coming to near this position. So whenever a spark is created, then there's some portion, some face-to-face portion became melted, and this metal and is just works like a filler material, and it's join each other. And this is the main procedure of this percussion welding. Percussion means is a rapidly. So it is a rapidly means rapidly you have to apply some force and apply some sparking condition. Whenever a sparking condition is provided by this capacitor discharge, and capacitor is charged and discharged by this rectifier section and this transformer section. In this way, we can provide the percussion welding. But the percussion welding is applied only for the thin material, just like a wire. Okay, not like a huge amount of high thick, thick, uh, thick rods are used here. So you can say application for application purpose, the telephone industry, where the wire telephone connecting or communication wire are joined, then we need some face-to-face joining. In this case, we are using some percussion welding. Okay, and filament, just like a filament which you want to join with this holder, then we are joining some percussion welding. And mainly in this case, we can also apply some dissimilar metal, just like maybe this metal is copper and this metal is made of tungsten, iridium. Then we can join this. Okay, so one main requirement is to producing is a thermocouple. Thermocouple has some two similar type of metal are joined. Then we can also apply this partition type of welding. Okay, so only advantages is that the rapid process, i.e. very less time is required, and that's why less power is required, and uh, more arc temperature is created in this case comparative to the flash and bar joining. And heat treatment parts may be also welded, and the heat is connected only at the two joining surface, not other portion. Okay, so in this case only this portion are heated, not other portion. And dissimilar metal can be joined here. This is the main advantages of this percussion type welding. Okay, and now uh, if you go for the disadvantage, you can find there is only bar joining is possible, not plate joining or the welding joining is required for here. Okay, so this is the main disadvantage of these things. And another is expensive equipments are required, because we need some controllable level rectification. We need some controllable charging, discharging, or switching operation. So it is the main thing that you have to apply some controller. You have to apply some sophisticated gadget to control it. So the cost became much high than other type of equipment. Okay, this is the main disadvantages of this percussion type welding. And the very small area, generally 230 millimeter square area, can be joined together. So if we part by part, step by step explain, then we can say supply voltage in DC type. Look, just part by step by step, just explaining. Meaning the supply provided in the DC type to a capacitor. Okay, first DC type of the supply is routed to the capacitor, but this DC is not continuous DC. Then it will not charge this. and this is the electrostatic capacitor. That's why called it is called uh, electrostatic. Okay, and the capacitor provides rapid discharge of electrical energy, which was stored in electrostatic capacitor. That's why it is also called the electrostatic welding. And then pressure is applied percussively. Means pressure also you have to apply some pressure rapidly, not for a long time, not for a very slow point. This is rapidly you have to some pressure, and when the sparking is occurring, and then whenever the distance is just 1.6 millimeter, then arc will be created because one fixed electrode is there and another movable electrode is coming to near this fixed electrode and fixed bar. Then whenever it is coming 1.6 millimeter, then a spark is created. At that moment we have to apply some force so that it will be joined, and this facial portion will be melted, and this melted metal joined together each one. So metal was melted and joined. Okay, this is the one by one partition welding. Okay, and now I am. This is all about resistance welding. Okay, and now if you have any question, you may ask me. And now I am going for the ultrasonic, and this is the picture of percussion welding. This is small type of welding materials are used here, and this is the ultrasonic welding. Okay, guys, you can see this is the ultrasonic welding. What is ultrasonic welding? In this process, ultrasonic waves, a ultrasonic waves is created, and in in this process, a ultrasonic waves or vibration used to generate heat it across this contact of this two material to metal, and this heat it is a produces a molten metal or the metal temperature so that it reach to into the plastic stage or the fusion point, and then it's became joined each other. Okay, so this is a process where ultrasonic vibration is used. Now, I want to just explain the construction of this type, and then I will explain the working principle. Look, here is some piston is there to provide some pressure to this plate, and this is the lower portion. This is fixed, and this is coming up and down, movable. This piston pressure is provided by either pneumatic or hydraulic or maybe any electric actuator. Okay, this is the pressure piston, and then it is coming as transducer. Generally, piezoelectric transducer are used here, and if we apply some AC current, and the frequency of this AC current and became much high, then what happens? A piezoelectric transducer produces a ultrasonic vibration. This is 20,000 to the 30,000 hertz. Okay, this is not audible sound, audible frequency. So between 20,000 in hertz to the 30,000 hertz, if we produce some ultrasonic vibration, and then it is became the ultrasonic vibration, and it is not audible, then a vibration signal will be produced. Okay, its power is not much high. This vibration is applied to the converter. This is what piezoelectric or the transducer is producing. This is a signal. This is a small strain. That's why it is called a signal type. But this signal is not effective to the joining, to the welding. Then we have to apply some converter. This converter converts the electric vibration signal into a mechanical vibration. It creates some mechanical vibration. Okay, Whenever this range mechanical vibration is created, this is 20 hertz to 20,000 hertz to the 30,000 hertz, then it's coming to the booster. Booster just concentrate and amplify these things, and it is supplied to the sensor probe. Okay, or it is called the sonotrope. This is just like a mechanical parts. This is a needle type mechanical parts, or you may say this is the horn, and this horn is touched with this contact, coming contact with the two metal where we want to join. And whenever this vibration is applied to this metal, uh, at the pinpoint or this just like a spot welding is at the area, and vibration is passing through this contact point. So what happens whenever this vibration is coming, then two metal body is coming to the touch, and it is vibrate it with each together, and within this period we are applying some pressure. The pressure and vibration means just like a friction is there. If you rub your two palms together, then automatically you can realize there is some temperature is in arise. And just like this, if we apply some high frequency, and then these two metal are coming together, then what happens? Then here some heat is produced, and this heat, because the 20,000 hertz to the 30,000 hertz frequency, this heat becomes just like a fusion temperature of these two metal. And what happens, these two contact faces became melted, uh, uh, melt, or you may say this is going to the plasma state, or you can say this is the plastic stage. And then we apply some pressure also. Among this we are apply some pressure. So what happens, some molten metal just going outside of this, and then if we release the pressure, then it will join each other. This is the main and fundamental things of ultrasonic welding in strategies. Now, if I one by one, if I explain the procedure, then you can understand these things. First, high frequency current then passes to the piezoelectric device. Then the transducer produces mechanical vibration. This is the vibration, but it is a signal type. And then the converter just uh, convert the mechanic signal vibration signal into a mechanical vibration. Then a booster just amplify the frequency. Then then it is coming to the horn. Then horn supply the high frequency mechanical vibration to the welding plate where we want to weld. Then what happens? The welding plate deforms to a plastic stage where the face-to-face contacts are there, region, or you can say the region of contact. Due to the mechanical force and the friction, heat is generated, which is helps to plastic deformation of this metal, and the weld, and then it will welded each other. And this is applied for wide wide variety of dissimilar metal. Okay, where we are going to join. So sometimes it is a question is arise, if you want to apply some dissimilar metal, but for the lab joining, which type of electrode which type of welding do you prefer? This is the ultrasonic welding. Okay. Now I am to talk about the advantages. This is clean, not external heat is required, and as this not external heat is required, you may say this is the solid state. It is precise because if how many vibration you are creating, that much heat, that much area will be covered. And so this is the precise, and that's why we can use it as an automation, because automation needs some precise. And if we apply some heat, then the temperature, then some feedback procedure also required. But we never get the temperature of this body, because here the temperature is directly proportional to the vibration. So if I control the vibration, then we can control the temperature. So the, controlling of the vibration is easy for any transmission or any control system. So that's why this is applied for any automated industry, and it is good surface finishing because no other hazardous area is required. Um, hazardous action is there. That's why no splattering is there. It is the smooth surface when hitting and high strain joint without applying some external heating. Coming out. And the disadvantage, not yes, yes, disadvantage, not applicable for thick material. It is only for the thin material, just 2.5 millimeter. It can be applicable. 2.5 millimeter thickness material can be used, and it is quite expensive also. And what else the application? Look, nuclear reactor. Nuclear, because if you go for other joining, there may be spotting, there is some leakage would be occurred. But in this case, this portion which are coming to the contact, this total portion we can join. That's why leakage free, and that's why we are applying for nuclear reaction, automation industry, chemical industry, industry, etc. Even as it is a clean, that's why we can use in the medical industry also. Okay, and the electric industry where the light or switch are joined or switch is manufactured, there also this type of welding are ultrasonic welding are applied. So this is all about the resistance and ultrasonic welding. Hope you can understand. If you have any question, please ask me. And now I am very much thankful to the Google uh, site where I get some images. It's from various site, and I am thankful to them. Okay, and guys, thank you to all of you. I stop here. Stop sharing. Guys, have you any questions? Okay, thank you.